official start, because I'm sure there is always some delays, and there was some confusion with the rooms between Amfiburg and the BDD. So I think that more people will come. And so I don't, to tell you the truth, I started thinking about making an introduction of Vale. And then I thought to myself that I want to do a large introduction on Ron. Because we feel that really Ron is part of the house, I'm sorry, for already some years. Of course, many of us who have worked on the cytoskeleton, cell biology, biochemistry, of course know, his contribution, discovery of kinesin, and many others. So it's very embarrassing, to really retrace the career of Ron. And although it's not so long career yet.
I don't know.
No, but it's true that he initially had a PhD in neuroscience in Stanford, but he was enrolled in an MD PhD program, by the way, and then he decided to pursue on research instead of doing a medical degree, and it's true that. Kinesin molecular motors, we all know that how important they are, but so this is one discovery and a large contribution, but of course there are many other contributions that came along. And so very quickly became an assistant professor at UCSF, and so we have been at UCSF, but we all know that, he also has been collaborating with many countries. He have been investing himself a lot, as I know, in India, and and always willing to give a lot. So you can, so you can close your ears, and then I can tell all the, just not to be embarrassing. And but it's true that the thing that I want to say is that just thank you, Ron, for being here. For giving so much to all of us. To young researchers, to old researchers, and I know that even the older researchers have been following the courses and workshops that you really, very openly you said, okay, I would like to come for 2 months. Do you want me to come? Oh, Ron, please come. And you are here now for these 2 months and really giving a lot of yourself, a lot of your time, and all your expertise. All scientific expertise, but all the expertise on how to give talks and today, about scientific publishing, which is really important. And of course, Ron had a lot of prizes, and I'm not going to name them, but what I think is really important that Ron, you're always open to discussions, and we don't feel that you don't make us feel very small, and it's this kindness that I think is appreciated also here, and being so generous of yourself. So thanks again, and I'm sure that maybe the questions will pop up during your talk, and I think you won't mind of that. And so thanks so much, and it is an embarrassing introduction. because other than being really a nice colleague, I think we always feel so much friendship that we all appreciate it. Thanks so much.
Thank you, Teresa. Well, thank you for that nice introduction, and it is indeed a pleasure to come here. This is kind of like a second home in Europe, I would say. The Curie is a fantastic place. I'm on the scientific advisory board here, and it's really nice to be able to spend a little time at the Curie. And so really, mostly what I'm doing is giving a set of talks to graduate students and postdocs about science communication. So that's the main topic. And I see a few people here, but most of this group is completely different, because I just gave a talk on how to give a scientific talk yesterday. And a couple of weeks ago, I gave a talk on how to write a scientific paper. And this is kind of the sequel of how to write a scientific paper, which is an activity you do yourself, but you realize that that activity is part of a bigger system that we all kind of live in the scientific community, which is a system in place for scientific publishing. And that's what I'd like to talk to you today about. And I think this is really not an issue of, well, it's partially an issue of personal responsibility, but I think it's really an issue of community responsibility to think about where we want this whole profession to be going. Remove that?
Yeah.
I was
you
told
were-
to talk into both of them. I don't,
Okay. No, but you're.
Scratching your shirt twice was like scratching your shirt.
gosh. You know what I really feel like doing? Ripping both of these off and
Just talk.
walking around the room and talking, but I've been told to like stand right here.
It's okay, you can. It's
Um,
you can move.
That's one of the first things I told the group yesterday about how to give a scientific talk, is not to stand behind the podium. That was like one of the major take-home points of yesterday. Some of the people are nodding. And so normally I would be out here talking to you because it would be much more engaging. But no, today I'm told to stand right here. But I'm just explaining to the students that I'm already forced to break rules that I told you yesterday. But anyway, so what I'm talking about is scientific publication. And you know, what I want to do in this talk is probably give you a talk for about 50 minutes, so a standard talk. But I'm really hoping to use the time after that a little bit as a town hall and get your input, discuss ideas for Curie, discuss ideas for Europe. I mean, honestly, there should be many more people here involved in this conversation, because this is a topic that affects everyone's career and personal lives in science. And the bottom line of this talk is, unless we have interest in it, unless we take interest in it, and unless we are interested in our own future here, it's not going to change. And it's not going to change, I would say, for the betterment of young people. But so I think I want to use the last part for community engagement. And just relevant for the introduction, a very nice introduction. You know, when I was a student, you know, one of the reasons I got a job is I published a lot of papers when I was a graduate student. And in fact, in 1 year, ended up publishing 5 papers in Cell, 4 as the first author. And I tell that to people today, and they might look and, oh my God, you know, you must be just an incredible scientist or something. Probably today, all of those papers would have been compressed into one. And it would have taken me much longer to get that single paper out. And that's kind of, in my career time, this is how far like scientific publishing has changed. So I really want to like take a moment to say, well, I should have changed this slide to say, where were we, where we are now, and where do we want to go in the future? But this is a poll that we took from an organization I'll describe later about kind of how the community is responding to scientific publishing. And you know, I show these statistics, and I've even been in some audiences where someone looks at this and said, I don't believe this data. And I ask them why. I said, I don't see where the 9% came from. So this is very different, I would say, from when, although I don't have statistics, when I was a student. You know, I remember actually looking forward to publishing a paper. I looked forward to getting the reviews back. And it was kind of an exciting time, you know, when you actually got to share what work you did with the community. And that's the way it should be. And honestly, that's the kind of culture around scientific publishing that we need to return to, quite honestly. And you know, you could say, how did we get into this particular situation where we've kind of moved into a situation of, I would say, this feeling that we're, you know, of dissatisfaction with the science communication process in terms of publishing. And, you know, I would say it's really the answer to this. I think we've just drifted here. And I think we've drifted here. There hasn't been anyone like intentionally responsible for this. There's no bad person or bad guy, or, you know, we like to like name like journals. I mean, or I think that's misplaced. I think to some extent we've been, as a scientific community, allowing the situation to happen. We've been kind of asleep at the wheel, and we've ended up here. And we suddenly find ourselves in this situation. And largely just by not paying enough attention and not by actually taking forward-looking responsible action. And I think this time has come when we need to pay attention. And that's part of what this talk is about. So the main messages are, but I want to give you a message of optimism, because I always approach everything with optimism. And although I think there is a level of dissatisfaction, I do deeply believe that change is possible. And I'll just show you an example from Preprints of how, and that's something that I've been very much involved in, how change has actually taken place much faster than I could have ever imagined. I'll spend a lot of time talking about that. But the other main message, which I've already been putting forth to you, is that the scientific community itself needs to take an active role in defining the future of publishing. Because this is about our career. This is about how we communicate science to one another. This is how we evaluate scientists within our community. This is our community responsibility. And if we don't care, it's very hard to get people outside of our profession, you know, journals and so forth, funding agencies. You know, we need to take ourselves a leadership role here. So that's the other message to convey. Now, the other thing I want to say about a publication is that the process of publication is actually not one action. It's actually embodying a number of important elements of about scientific communication. So one element of a scientific publication is dissemination. That's an important goal. So we want our work to get out from our laboratory out into the scientific community. That's our responsibility as scientists. That's what we are ultimately paid to do, is we're paid to develop knowledge, share that knowledge, and have that knowledge be used by others to you know, further science overall. The other element is that we want that work to be credible. We want that data to be examined. We want that work to be improved. And you know, that's kind of an internal responsibility of our own scientific community to make sure that the work that we communicate is examined and reviewed, and you know, with the spirit, I would say, of also trying to improve it. And the last thing that we use the scientific publication is we use it as a form of, you know, evaluating the work that we do as individuals. So the scientific publication is a product. It's a product of our work. And that work indeed has to be evaluated and judged and for its merit. That's how we get grants. That's how we get jobs. That is just the way the scientific system works. That's the way most systems work. The work that you produce has to be evaluated somehow. So, but all of these elements are embodied in the single action right now of a journal publication. I'm going to make the argument that I think a lot of these elements of publication can be uncoupled from one another. They don't all have to be bundled up together. And I'll use that as an example for preprints. So I want to just take a step back and just tell you a little bit about how I got interested in this problem in the first place. And my interest in publication didn't actually come through whatever, a long-standing decades interest or activism in, you know, open access or something. My route to this problem came through really thinking about this particular problem here, which is the time it's taking for training and independence in science. And you know, I was very lucky, but I got my first job at 27. I think I got my first NIH grant at 28 or 29. And you can see, like, just over time, what's happened, at least in the US, and I'm sure this is true in Europe as well, that these are the time to getting a first R01 grant. That's the middle line over there. The time of getting a first NIH grant is drifting higher and higher into the early 40s. And the median age of an NIH grant, that's the top line over there, is getting older and older. So, you know, we're making young people wait longer and longer to become independent in science. And I think a lot of people that think deeply about what's good for science feel that this trend is very undesirable. Young people have a lot of energy, and you know, they want to get established in a career. That's not an unreasonable request. And so something has to be done about this. We have to start finding ways to reduce this trend of overall training and time to independence. Now, this is a problem that is very complicated. It has multiple elements to it. So I'm not pretending that all of this issue resides just on publication. But it is true that if you don't think about publication, I would argue you're not going to solve this problem. And that is that the reason that that's true is that at each of these transition points, a key gatekeeper that we all know exists is publications. At each of these transition points, having some evidence of what you produced is critical for you to go from a graduate student to a postdoc, from a postdoc to a faculty member, to get grants, etc. So I first began to look at this question, you know, whether is the way that we're publishing right now, are the trends for scientific publication contributing to this increasing time of training? So that was the question I kind of came into this problem with. And some of this was analyzed in this particular paper here, which I'll talk to some extent about, which was published a few years ago. And I'll tell you some of the data that was found in that paper, first of all. So one thing that I did is I actually looked at publications from graduate students at UCSF in the past and as they are today, just to see if there are any changes in kind of the publications of graduate students. And I chose for this 5 graduate programs, and I picked those because those are graduate programs that existed in the early 80s and also exist today. So they're exact same programs. Another interesting point here is, and this is like, I think, the situation that's occurred with proliferation of training, number of people we're training in the system. For 2 years of data in more recent times, it took me 11 years to collect not even the same number of students. So I was trying to compare a comparable number of students. So you can see like the trends in the increasing size of graduate programs that's occurred over time. But so here's the data. So I analyzed this group of students for these parameters here, which is graduation time. The time from when the student entered graduate school to when they first published a paper. I should also emphasize that PhD program is a little different in the US. It's effectively a combined master's PhD. We have no master's programs, so you can consider this a little bit similar to a combined master's, but the first year is coursework. Second year, you start working in your PhD lab. I looked at the number of first author publications, and just for interest, looked at the number of papers that are published in, I think, what we would currently accept as high-profile journals, Cell Science and Nature. Okay, so first of all, the time for graduation has gone up. It's a little bit over 6 years. That number has been verified, by independent metrics at UCSF. So if anything, it's going in the wrong direction here. Theoretically, at UCSF, 6 years is kind of the term limit for a PhD, although we don't obey it. There are 7-year PhDs and occasionally some drifting longer. But the goal is to graduate everyone by 6 years. Now here's the problem, and this data really surprised me, that when I really examined all the data for time to publication, before it was 4.7 years, and now the mean is 6 years. So 6 years, now of course there's spread in that data. Some students publish very fast, some students take longer than 6 years. The point is that the median time to get your first author publication is at the time limit for what we consider the acceptable time of graduation at UCSF. So unless you solve that problem, and if you're making publications kind of a requirement for graduation, it's going to be very hard to shorten your graduation time. The other thing, and I mentioned this to the students are getting less chance to publish papers. So in the past, students published around a little over 2 papers as first author in their PhD, and now the number is 1.4. So that number has gone down. And even though I would say students worry about getting high-profile papers in Cell Science and Nature far more now than they used to, I don't have data for that. That's just an impression. But it is 3 times less likely that that's going to happen. So that is all the data. And you could say, OK, so why is it taking longer for students and postdocs to publish their papers? And I think, well, the answer, I think, is severalfold. But one, and I'm going to make an argument for this, is that the bar, what is required to publish something, has been rising and rising and rising over time. That's kind of why I mentioned, not because I wanted to self-glorify myself, but that example I had of the cell papers that I published as a graduate student just would never happen today. And I think the other reason is that the publication process itself is very unpredictable. If you're a late-year graduate student, you submit a paper, it's very hard to know what the path of that paper is and how long it's going to take to be accepted. How many journals you're going to have to apply to. So the publication process itself, in terms of time, is now very unpredictable. It could take 3 months. It could take a year. In some cases, it takes longer than a year. And you can't even plan around that because you don't really know. OK, so one of the things I'll come to is the rising bar of data for publication. And this is data that I gathered with the help of a couple graduate students in the lab. But it compares the number of panels that are published in these journals in a single paper. And we kind of looked at this a little bit subjectively to analyze, again, comparing them 1984 to 2014, so a span of 30 years. We did do some analysis to look at what we call a panel to make sure that what a panel in the past, what was considered a panel, is comparable to what people are calling a panel today in a paper. And I think the short answer to this is yes, people are using panels in roughly similar ways. Approximately 2/3 of the panels in papers correspond to kind of a unique piece of data. About 1/3 of them are kind of versions of the same piece of data. But so maybe the number of panels you can divide by 0.6 to come up with the amount of independent data in a paper. But you can see that the number of panels in the paper, the number of figures has not changed. So there was the same figure rules in cell science, and I'm not sure about JCB, I can't remember anymore. But the rules for the number of figures have not changed over time. What has changed is the number of panels in a figure. So they've gone up about, around threefold if you look 1984 to 2014. And that does not include supplemental data. So supplemental data did not exist in 1984. So if you add the number of supplemental data, it's probably gone up about sixfold. Now, it's a hard thing to say it's really a sixfold increase. It's easier to make figures now. In many cases, it's easier to get data than it used to be for some things. But I would also say it's not, however you look at it, there's still a considerable increase of data going into papers now than there was in the past. And more authors are collecting that data. So if you look at the number of authors per paper, again, there's a it's pretty matching, actually, in terms of the number of increase in author number that are co-authoring papers. So why is that? And here I'll just, and why has this happened? And here's an example of why I think we've just drifted into this situation rather unintentionally. And I'm going to make an analogy here to real estate. And I think I'm not an economist, so I will preface that. But from my rudimentary understanding of economics, it's supply and demand. I'm not sure it goes that far beyond that. But the supply of the number of cell science and nature papers has been limited. The real estate in these journals, amazingly, has remained the same over 30 years or has gone down. Even though, in reality, there's a lot more technology right now to handle and print and process. A lot of things actually have improved in efficiency over time for a lot of other industries and make possible to process more things. But if you look at this data, the number of papers in the journal in a year has not changed. In some cases, actually has gone down. If you look at Journal of Cell Biology, the number of papers actually decreased. Even though, as we all know, the number of scientists in the world has gone up. The number of total papers published on PubMed has gone up dramatically. The number of countries, I would say, that are even participating in the Global Science Network has gone up. So what happens? Well, it's just like buying a a really nice flat in Paris. There are only so many really nice flats in Paris. The real estate in central Paris is not increasing over time. The number of people that want that nice flat in Paris has gone up. And so what happens? It costs you more money to buy that flat now in central Paris than it did 30 years ago. Well, if you want that nice real estate in cell science and nature, it's going to cost you more to get that. And in this case, you're not exchanging money. You're exchanging data. And you're kind of exchanging also time, because it takes time to get that data. And if you're looking at manuscripts as an editor, and I would do the same thing if I was an editor. Which paper am I going to take? I'm not really concerned about whether, let's see, this postdoc, that was 6 years of their life that went into that paper, and this postdoc, well, that's only 2. So I'm going to weigh them. Of course, you're just going to take which paper is like bigger, more complete, bigger impact, and so forth. So I think this is something like what's happened. So in part, we've created this system of artificial scarcity. It's not real scarcity. I mean, it's possible to process more papers than this. PLOS One has done that. They can process large amounts of papers. But, this is kind of just a very human situation. And, the more difficult it is to get something, the more desirable it is. That's just human nature, right? And of course, we feed that ourselves. We do this ourselves if it's to one another. If it's hard to get into one of these journals and you've got it, you must be very special. And therefore, it's really just what we value as a scientific community, and what is scarce to get, what is difficult to get, must be good. And of course, the scarcer it is, the more difficult it is, the harder we work to get, to get it. So we've kind of created this psychological trend that has valued that real estate. And this is the predicament that we're in right now. And it's a difficult predicament to get out of this addiction that I would say we have internally as a scientific community. Okay, but I would say the general problems with this is if it's difficult to get, we spend more time getting it. And, but all that time, that work is not out there available for the rest of the scientific community to use. And so I think we've now come to the situation that information is being held in laboratories for longer. And this is my personal opinion. I don't have data on it, but I think less unpublished information is being shared at meetings. It's like people are willing to talk if they're pretty close or have gotten publication. So we've now gotten the situation where we're really not doing what's best for science in a way, because information is really what makes science grow. I think it's led to longer training periods for students and postdocs. It's led to a lot of wasted resources, because to get that highly desirable, difficult to get publication, we're willing to do, serial submissions, rejections, and so forth to, try to get our paper published. And you think about all the time that our community is spending doing this, as well as editorial work at journals, that still requires someone to be paid to do that, peer reviewers to do that. All of this wasted time here going into getting what is highly desirable, that's a lot of actually human time and, I would say, financial resources that could be better spent on something else. And And this concerns me too. I think students and postdocs shouldn't have so much worry about where they publish. I don't think it's. I think they should be focusing on doing really good science, enjoying the profession, and learning to be good scientists. And if a lot of the career, especially when you're young, is spent worrying about where you're going to be published, I think the career is going to get less desirable for many, many people, and I just think that's something we have to change. I don't think it's fair. I don't think it's fair to young people, quite frankly. So, the question is, I think we have to think about this at a higher level. And what I mean by a higher level, too, is I think we have to think about what is really good for science. And the reason I say that is the public is giving all of us money, to increase knowledge, to solve problems, facilitate human health, etc. And we have to think of a way in which we communicate our data in a way that serves that goal. And I think we can't lose sight of that. I know that some of it is all of our careers. We want our, as individuals, as scientists, we also want to prosper and we want to get on with our careers. But there's a bigger mission here, and we're part of that bigger mission. And I think we can't lose sight of that. And the other reason is I do think we have to think about what is healthy and good for the whole scientific community as well. Okay, so yeah, basically, I think what we want is obvious. We want, a future with better peer review. We want faster, less expensive, and more efficient publication. We want better ways to evaluate the merit of our scientific work than the current system. And of course, we want open access to that information. I'm not going to really talk very much about this. Of course, Europe is leading the way here with Plan S. But the way I just frame that doesn't seem very unreasonable. So, the question is, how do we get there? And how we get there is not easy, because publication is wrapped up with a lot of stakeholders right now. And moving the publication system forward in a good direction requires all of these parties to kind of move in some kind of synchronous direction. And these are the parties here. Even in our own community, I think getting junior and senior scientists on board is something that, and university committees, that's even within our community, that's even not trivial. So I think this is, one of the things that has to happen. So I will tell you a little bit about one thing about, which I think is a positive message, about how these different parties can work together to make positive solutions. And that's an example of preprints. So how many people here know about preprints, just as an example? OK. How many people here have submitted a preprint? OK. So even, that's pretty good. And I'll come back to this. A few years ago, when I started this room, there would be no hands up in the room in a life science community. But anyway, I think everyone's familiar with this. So I'm going to explain just briefly what a preprint is. Of course, this is what we do. We submit a paper to a journal. It can get rejected by the editor. We try again. It may go to peer review. It can get rejected. Eventually the world sees it at the very end. Preprints can exist with this system. I would say from the very start, it's not an either-or situation. It's a both situation. This whole process, as I said, is very unpredictable in terms of time. It could take a few months. It could take over a year. You don't know. And you don't have total control over that. With a preprint, you as a scientist have the choice of deciding when your work is shared with the community. It's just as simple as that. It's largely the same product. It's a manuscript that's come out of your lab. And it's a manuscript that gets uploaded on a public server. So it's made public. It has like a citable reference. It has a DOI number. And usually after like 1 or 2 days of screening, just to make sure it's not pseudoscience, that preprint gets posted and anyone for free around the world can view it. And that can happen while your paper is somewhere in that pipeline above, and that allows people to view your scientific work immediately. Now, of course, like if we had to think of this now, it would never happen. But fortunately, the physicists figured this out many years ago. And they figured it out even before there was a World Wide Web. So remember, the particle physicists and so forth developed the World Wide Web. And they did so because of information sharing. And Paul Ginsberg developed the first, computer sitting on his desk before even there was a World Wide Web as a way of sharing data between scientists in the particle and theoretical physics community. Now, it's pretty much what, not universally, it depends on the community of physicists, but like in many communities of physics, this is pretty much how they do business. If you're a particle physicist, you wake up in the morning, you have a cup of coffee, and you look at what comes up on Archive. It's just the way they work. And there are 100,000 preprints posted per year at a cost, I should say, of $10 per posting. And that's how much the cost of running Archive is. So the question is, would a preprint server work in biology? So I actually came to this question because I started writing this article about all of this data that I just showed you and the reason why students are graduating longer. And it's kind of a bummer to write an article that states a lot of problems but doesn't have a solution. So before I published this, I did a lot of research on Archive. I talked to Paul Ginsberg. I learned a lot about the physics use of preprints. I hardly knew about it myself. So I spent a long time just educating myself about what a preprint is, how it actually works. And as you'll see, and there was a preprint server already up in biology called Bioarchive from Cold Spring Harbor. But you could see the usage statistics of Bioarchive compared to Archive, even though our community is probably 10 times greater than the physics community. There's a vast mismatch here. So what I learned as I began learning more about preprints, I found out, first of all, most biologists had never heard of them. Or maybe they heard of them, they didn't really know what it was. So that probably classified over 99% of biologists. The ones that did know about it or had heard about it, their concern was, if you let people post their own work, it's just all kinds of crap is going to come out on this server, and we're going to lose control. It's all going to be crap. This is still a problem, but this is the other reaction that biologists have, that preprints will lead to more scooping. So the ones that thought about it. Now it's interesting because in the physics community, it's actually 180 degrees the opposite. People use preprint servers, as a way of exchanging information, getting credit, and not getting scooped. So it's a 180-degree difference. And then a lot of biologists said, it just can't work because physicists are some very different people, and it's just the culture is completely different. We biologists, it just won't work. So, and there are other issues that preprints were not recognized by funding agencies or universities. Many journals did not have a preprint policy at all, and some had a negative preprint policy. But I would say optimistically, like a few years later, preprints have grown nearly by 25-fold. 25-fold versus still, I don't know what that increase is, 40% increase for physics. So you can see, I mean, this is still a small number for preprints, but in a small amount of time, I would say the biology community has started to adopt it. Okay, so this article, as I said, ended with the question posed in this that maybe preprinting would be a good step forward to allow biologists to start sharing their work faster than they are right now. And one of the reasons kind of came to this is that this is something that our community has control of. We as a scientist can decide. We don't have to wait for journals to change. We don't have to wait for anything else to happen. We make the decision ourselves. It's a system that really operates at very large scale, at low cost, and there's precedent from the physics community that it actually works. So at least there was a chance. Now, this was my very first preprint. So before publishing this in PNAS, this was submitted in early July. Same day submitted to Bioarchive and PNAS. And towards the end of August, I got 2 people had seen my work. 2 reviewers saw my work, and they gave me some feedback. In that intervening time, there were, largely through social media, there were 5,000–6,000 downloads of this paper, a large sharing in social media, and a lot of people sending me emails directly, giving me feedback. So in this time where 2 people saw the work was considerably discussed. In fact, I put this paper, this figure, in the revision of the PNAS article. So it was an experiment within an experiment, because this actually led to a figure that was in the paper. And the thing was published eventually in 2015. Now you could say, okay, what does that matter, July, November? Well, actually, there was so much feedback in interesting ways during this time period that it was kind of interesting and positive that I kind of decided, along with a couple colleagues, 2 young people, Jessica Polka and Daniel Colin-Ramos, and a Nobel Prize winner, Harold Varmus, to have a meeting on that subject. So we triggered that meeting in August, based upon the feasibility that something could happen in this space. We didn't have to wait until like 2015, because we had plenty of feedback very quickly on that. That led to this meeting here to discuss whether biologists should use preprints. And I'm presenting this because I think this is potentially a good way for the community to think about a lot of issues. It was junior scientists, senior scientists, all the stakeholders I talked about, journals, funding agencies, heads of universities, very, very young, old, diverse stakeholder group in this room, all discussing this issue about whether preprints would be a good path forward for the biology community. We had no idea what the outcome of this was going to be, quite honestly. But a really strong consensus emerged from multiple stakeholders that preprints could be a very valuable supplement to the journal system. And it was all because we actually discussed, we debated this issue also on live stream. So this was publicly available event. It wasn't behind closed doors. A lot of young people had viewing parties at their institutions about it. And there was a paper that came out, kind of a policy paper that came out later in Science, which was an interesting experiment also. There was around 25 authors, different stakeholders writing from their own perspective of why they thought preprints were valuable. And maybe I'll just go through that briefly. But I think the advantages for the scientific community is that you can control when that paper comes out. in the journal system, it's, as I said, unpredictable. But here you define the date when your paper is communicated, when you think your paper is ready to be communicated to the rest of the community. And about this crap issue, I could just tell you that my students worry far more about posting their preprint than submitting a journal article. And the reason is that the most valuable thing you have is your reputation. And if you submit to a journal, you can make a mistake because an editor, a couple reviewers, behind closed doors see it. If you post it as a preprint, everyone in the community, your community, sees it, and they make a judgment about you. So it's evidence for productivity, for jobs, promotions, grants. It allows immediate visibility of your work, so people get invited to meetings. And I'll give you some examples to this. You get more feedback, as I did. You can change your paper in positive ways prior to publication. And it potentially is an opportunity also to publish some shorter stories that may be very difficult or very costly to publish elsewhere. And it's free, so can't argue with that. And the point is, scientists are using preprints. I mean, this is the Bioarchive usage now over the last few years. And it's accelerating at something like Moore's Law over here. These are the number of people using the preprints. Again, accelerating exponentially. So these are actually getting used now for dissemination of information. Institutions are changing policy. So people are now writing that they want to see preprints in hiring decisions and tenure packages. And there are a lot of stories about, I've heard this in many cases, that preprints are actually helping people get jobs and get, it doesn't substitute for a publication. I should say, nor does it do so in the physics community either. They still use journals. But this is allowing people to get their work seen in a public venue by people that are involved in the next career transition. A lot of people are using preprints for journal clubs, including, I found out, the head of the NIH, Francis Collins, has a preprint journal club. So a lot of people are beginning to use preprints. And the advantages, I should say, for funding agencies, okay, this is their main mission. They want knowledge to grow and be shared and spread and advance science overall. So that's key on their mission. It allows their reviewers to see the most recent work by the applicant. Usually the most recent work is the most relevant to that being discussed in the grant. But it's not behind closed doors. It's in a public venue where the grant reviewers, but anyone can see that work. And of course, preprint is immediately open access. So what's happened is a lot of funding agencies have shifted their policies. And even for journals, it gives them, and I'll show this in a second, an access to potential new submissions. They also recognize that comments on a preprint can be helpful for improving the quality of the work, which of course they're interested in. And even in some cases, if there is a problem with the work, a lot of that gets worked out very quickly by the community itself well before it becomes like a formal publication. And there are lots of examples of that in the physics community. And I think we all know examples where work came out in very high-profile journals that was very quickly found out to be incorrect. So journals have started changing their policy about not only allowing preprints, but actively scouring preprints as a way of looking for material for their journal. So a lot of the journal philosophy is really completely flipped around. And some journals are even contacting authors now to submit their work. I mean, this hasn't, is not fully occurring right now, but the fact that it's happening at all, I think, would have been unimaginable a number of years ago. So just to say, all of this happened, you know, in a very, very short period of time. And, you know, honestly, I would have never, I mean, I'm always hopeful when I start a project, but I would have never imagined the rate of change that has happened in this area in such a short period of time. I mean, in my wildest dreams, I never would have thought this would happen. And I guess that's the encouraging message to a lot of young people here, that if the community really gets on board and it's in the spirit of science, you know, change can happen. And I think what I'm going to do is just kind of end it. Well, actually, I was going to discuss a few other issues, but I'm just going to end with preprints. I think it's still a long way to go. We can talk about this. There's still a very prevalent fear of scooping. Many biologists still do not know about preprints. And I think one problem right now is preprints are kind of considered a temporary work before the published paper. And I think making sure that preprints eventually get linked to published papers, so it's a continuum of a scholarly record, is going to be important in the future. And I think there's a need for more proactive institutional policies as well supporting that. As a result of that first meeting, we weren't predicting that, but a lot of funding agencies came to us and said, you know, you should start a nonprofit organization around this. I mean, we were just four scientists trying to do some good for the world. You know, it was a total grassroots movement. But now at least we're funded. It's a 501c3, amazing individual, Jessica Polka, who really, you know, she decided to transition from her postdoc work to lead this whole effort because she really believes in it. And she's really an amazing individual. And it's still like an effort to really create a scientist-led organization to improve publication, promote preprints. But we're also doing work to promote advocacy in peer review transparency, which I'm happy to talk about. And what I mean by that is that all of the peer reviewing that we do right now is behind closed doors. We have no access to it. A few journals publish peer review, EMBO, eLife being a couple. But the basic question is, if we value peer review so much, we think it is a really important scholarly endeavor, then why are we throwing 98% of it away? Which is, I think, a reasonable question to ask ourselves. And so we had a meeting on this question to try to, and I think, again, came out very positive that not the names of reviewers, but the work of peer reviewing should be made available. And we're also thinking about new ways of promoting experiments and evaluating papers. So maybe that's where I'll leave it. I mean, I think from an institutional perspective, I think Curie could ask itself, too, a lot of questions. Like, you know, what are our policies for preprints? Do we have a preprint policy at the Curie? What are our values for evaluating scientists? You know, when we look at promotion of people, what is our value statement on how we evaluate scientific work? Are we counting papers or high-profile papers, or do we have, you know, our own internal metrics and standards? So, you know, I think that this is an issue that really scientists should care deeply about. I think it's an issue that institutions should care deeply about. And all I can tell you is we are not done. I mean, preprints is just, it was never intended to be the solution. It was just intended to solve one problem, which is getting our work out faster to the community. But the bigger goal involves many other things. It involves peer review, it involves evaluation, it involves open science. I think the next few years, I predict in 10 years we are going to see something different. And the real question is, what we create in 10 years, is it really what we want to see created? But things are happening now at an amazing rate. And like a lot of things, there's an opportunity to do it well, and there's an opportunity to not do it well. And I don't think we can be asleep at the wheel for these next 10 years. So with that, I'll answer any questions that you have.
I do have a question is how many papers stay as preprints without never being published? Do we have a backup on that?
Yeah, I'm not sure I know the data. I know that data for the physics community. It's about, well, definitely over 80% of papers are published. And I think if one subtracts some things like conference proceedings and a few things that are, most, it like gets close to 90% of stuff is published. And that's even in the physics community, which values preprints a lot more than biologists. So I suspect that in the biology community, it's very, very high right now. But I don't know the exact number for that.
Because how long is a paper allowed to be a preprint?
Ever. Forever.
It can stay as a preprint.
Yeah, I mean, there are cases, I mean, I would say they're not frequent, of people winning, like, the field medal for a preprint, that was never published. So, I mean, the physics community, physics and math community, and my understanding, the math community in particular, although I'm not a mathematician, is it takes them a lot longer to publish because the peer review is very long, because they're actually trying to validate the, the theorem that's coming out. But, the physics community is not waiting to see where this is coming out before they judge the merit of the work. But I think the bottom line is that, it's interesting. There's a bigger question where this whole system is going to evolve. And, because you could imagine like different roles for journals than they are now. I mean, right now, like you think about the old days, like you sent something to a journal, you mailed it, and the journal really handled all the work. And, actually dissemination was difficult. You had to make print, you had to print something. You had to post it, like,
ship it.
Yeah. Yeah, so I think, in the digital age, one has to think, probably the value creation is not just so much in that anymore, which used to be fundamental. But, part of the value creation right now is, I mean, the community still feels peer review is very important. We are going to try ASAP Bio and EMBO. I'm not ready to disclose it right now, but are going to try a new experiment in peer review. So, but I think there are new creative ways to think about peer review from a traditional way. And I think there are new ways to think about evaluation. I mean, evaluation is, I would say, the hardest problem to solve. For several reasons. I'll go into this for 1 second. And the reason why I think it's very hard to solve is it's, first of all, inherently difficult to judge science. It always will be. It's very easy for me to judge my Airbnb in Paris and communicate it to other people of how good or bad that Airbnb is. So there are a lot of crowdsourcing things that work really well. But when you get to science, a lot of people feel very uncomfortable about crowdsourcing, I think for good reason. But it's debatable. But the point is, like, first of all, it's just difficult to judge good science. It just is. And we all know science changes over time, too. But the other reason is you say, OK, well, everyone read papers. It's just not the reality of the world. I mean, the reality of the world is scientists are very overburdened in their time. And with that limited time, it is very easy to judge work based upon where it is published right now. That's just the reality. And that is solving a need that scientists have, that they are too busy to read everything. But the current system for evaluation, I would say, also just makes zero sense. It makes zero sense in the sense that it's three people. It's think about statistics. It's three people judging the work with an editor in a completely non-transparent way to make career decisions for someone's job or grant or whatever. I mean, because it does have that impact. It does have that level of impact. And you're using small number of statistics to determine these things that are hugely important. So the small numbers, just the level of that small number just makes no sense. And the value really doesn't change over time. If it's a Nature paper was found out to be crap 3 months later, it still looks like a Nature paper. And so, they're just and the other thing that makes no sense is the huge economic waste that's involved, because what everyone tries to do is, if there's a hierarchy game, everyone starts off at the highest possible hierarchy that they could imagine and go usually a little bit above that, because they realize there's some stochastic chance that maybe they'll get lucky. Yeah. So everyone aims in the hierarchy at some level in a way that will best suit their career. And of course, that often fails and they get rejected. And as I said before, so they're doing that not to publish the work, and share it. They're doing the serial submission thing to determine what stratification their paper is in for some judgment that's going downstream. And that just makes no sense at all when you really think about it, because it's just wasting a huge amount of resources in the system. So between the small numbers game and the redundant waste of effort and so forth, the way we're evaluating scientists now just makes no sense. So the role of a journal in determining both publication and evaluation for the work probably will evolve to something else too. I think we still need some kind of thing. You can call it a journal. You can call it a post-publication journal. You could call it whatever you like. You need some kind of curation system. But what that curation system will look like may be something different in 10 years than it is today.
So Claude, so can you just introduce yourself if you ask questions?
I'm Claude Anthony. I used to be at the Curie. I'm emeritus now, retired. No, just one word shocked me when you started the talk and you said publication is a product. And maybe most of the problem come from that. We handle now publication, which in the past or last century, these were basic observation of nature. People would write, with ink a report, I observed that, or you mentioned physics. There's lots of amateurs in physics that observe the sky and they make basic observations, which are extremely important, that help the science. They were respected as observation. Now, if we handle the science as product, your paper is a product, it's a marketing stuff. We go to another system. So maybe damage.
Yeah, I mean, I think it's an important perspective that you're raising, that you know, how we communicate science has been different in the past, and there's no reason to think that it is going to be the way it is right now. Yeah, it's probably going to, I mean, you know, Darwin took like whatever, I can't, don't quote me on the years, but like 18 years to write, his theory of evolution. And of course, you know, in part because he was going to get scooped by, you know, by Wallace, you know, so.
Yeah, exactly.
But, you know, it played out on a time scale that scientists cannot believe today, you know, like that anyone would even write a book, you know, to communicate their findings. When today everyone's striving to get a 1,500-word, you know, Nature paper with, you know, 20 supplemental figures. So, you know, the way we communicate science has been changing and evolving, and it probably will evolve yet again in, you know, some other ways. I think, you know, the difference that you said is like science in those days was very, very small. It wasn't much of an industry. It was, you know, amateurs. There were, you know, people sending letters to the, you know, Royal Society. I mean, it was just a very, you know, different small world of how science. And, you know, now it's a much bigger world. So, you know, changing the ship, it's not a little rowboat. It's the Queen Mary out there that you need to steer in a new direction. So, you know, with many, as I said, many stakeholders involved.
Question? Yes?
So I just have like a, I mean, maybe it's kind of a superficial question, but about the, I mean, how manuscripts are presented as preprints. So very often they're just, you know, you have your manuscript in manuscript form that you submit to a journal, and you put it up on a preprint server, and then you have this kind of beast of a manuscript where you have everything, you know, double spaced, and it's very long, and you have figures at the back.
Yeah.
It's a very different like reading experience versus like a nicely formatted paper. And I still feel like this is really different in physics because a lot of people just write manuscripts in LaTeX, and it's very easy to format, so it's a nice reading experience. But I still feel like that's very different in biology. So do you think, are there ways like to make that a bit easier, or should we just learn to put up with that, or?
Yeah, well, Bioarchive soon, I think, is going to put, I don't know when soon is, but they have a plan to put things in HTML. And, you know, that will make it easier to read, more, you know, journal-like. I mean, part of the problem, even with there, which should be a solvable problem, it doesn't seem like landing, you know, Elon Musk is starting a colony on Mars. We should be able to, like, find a way to take, you know, a PDF or a Word document and convert it to HTML with very high degree of accuracy, right? But even that technology does not exist right now. And from my understanding, you know, it's partly because no one has really prioritized it. And also not at an open source level. But I think if really there was, I mean, think of how many billions of dollars we spend on publishing. I mean, billions of dollars. That if someone like invested a tiny fraction of that and said, you know, let's develop an open source PDF to HTML software, that could make a huge impact in the whole industry. Because right now it's like, and it will change, but you know, it's mostly being sent to India or places like that to do final HTML conversions. But yeah, so if you had an automated way, it would save an enormous amount of cost in the whole publishing system. It would help preprints a lot. You know, you post it, maybe there's certain fields that you have to fill in, and it repopulates it as a, you know, an HTML document. It would also make it easier for, you know, machine access. there are a lot of people that are very interested in like machine access to papers. Like right now, it's like we read the paper, we have to figure this out. But there are millions of papers, you know, being published. And you also could imagine a future where actually machines are scouring a lot of the literature for you in a much more sophisticated way than typing in on PubMed, you know, a few keywords. And I'm sure that future is going to come too. A big barrier for that future is licensing. You think that's not a big issue. And again, most scientists don't know about licensing, couldn't care less about licensing, et cetera. But, you know, how your work is licensed, even as a preprint, can have a big influence on the usage of that preprint, let alone journals that own the license, you know, to your figure and data and so forth. So, you know, even like the future of machine access may involve issues like licensing, which you know, we don't talk about as a community at all. Yeah.
Go ahead.
Just one question. I was wondering, maybe.
Can you speak loud? Because in this interchange it's very
So
difficult.
if it could be a solution to not use anymore journals like they are right now, and to have only journals on institutions. So you have like your institution can decide, or your colleague review your work, and it's published with your name, and then the evaluation and the rating of your work is only made by the citation. So it doesn't have anymore the label of the journal, but it's only it will be only the citation.
Yeah, so I mean, there's some good ideas there. I mean, you could imagine, as you said, it could be an institution, it could be, you know, funding agency, it could be something else that is just, you know, creating a system that maybe incorporates some kind of peer review, but is just getting the work out there. So, you know, and I know HHMI is very interested in this as well, that, you know, you publish and then something happens where you're evaluated, but you don't have this complicated system of wrapping up evaluation and publication. That's kind of what I was referring to too. Now, whether that's the act of, and then the cost may come down dramatically too. You know, Faculty 1000, you know, system a little bit like this, it costs like $1,000 to publish, as opposed to like $5,000 and $4,000 at some other journals. The one issue with citation is, I mean, it's a good solution for me because, like, I am old and I can wait for 5 years because I have a stable job, and I can wait 5 years to see how many people cite my paper. But you can't. In other words, like, if you're just using citation as a metric to advance your career, it's too slow. It's just inherently too slow because people have to read your work, then they have to finish their work, and then they have to incorporate your reference in their work, and then they have to, you know, and you're looking for a job like on a 6 month time scale. So I think this is the tricky bit. There's some interesting longer term networking solutions that may work for senior scientists, but I think we're not the real problem. I mean, we shouldn't be the focus. We need to figure out a focus that's really going to work for young scientists. And that goes back to where I was at the very beginning. I mean, you know, what are we trying to do with this pipeline? So this is why it's, you know, this is why the evaluation piece is a difficult problem because, I mean, I have some ideas around it, but it has to operate on a fast time scale that's consistent with trainees.
But then if you
Well, yeah, no, I mean, so you could imagine other kinds of ways. I mean, I could imagine, let's say, the membrane community just deciding to self-organize itself and saying, we're going to curate, we're going to have an advisory board, and we are going to curate and periodically discuss every quarter all the work that has come out in the membrane field. And, and we're going to evaluate that work and, in some way and post what our evaluations are at a bigger scale number than 3. So you can imagine things like this happening. And again, I think those are solutions that are self-organizing. We don't need to wait for journals to change, because they may not. So I do think there are parts of the evaluation problem that our own community could take self-action, again, like preprints, in ways that would produce productive evaluation things. I mean, we're doing it anyway. It's like whether it's a Nature paper, there are scientists there who are, there are 3 of them, we don't know who they are making that judgment somehow, and they are comparing across their field in a very difficult to understand way. But if the paper comes, this is the other problem where I think we've kind of screwed up peer review in favor of evaluation. Because I think what people are largely doing now in peer review, especially for elite journals, is first of all, they are comparing that work to everything else in their field and saying, they're advising the journal, is this the very top work that you should be accepting in your field? So it's still the scientists that are providing that judgment to the journal. So we are still doing the work of all of that evaluation. But I think also the problem with that system right now is that, in addition to being small numbers, I don't have data for this, but I think scientists are spending too much time now advising the journal on whether they should take it or not, and not spending enough time looking at the scientific paper and evaluating the science. And we've all seen this. Like, this paper is not of a sufficient general interest for blah, blah, blah journal, in which case you're done. Your job as a reviewer is done. And then you put some little thing about figure 3 or whatever. But, I think we've gotten into this habit of not really evaluating scientific credibility, but acting as an advisor for determining whether that paper is matched for some mythical scheme that we've created of hierarchy of where that. And I don't think that's what peer review should be for. I think peer review should be about looking at the scientific credibility and improving the scientific work. That's one problem. The second problem is the reason why that data escalation has occurred, we are doing it. It's not the journal, we are doing it. And the reason why we drifted into that is then we say, well, my paper was rejected by X journal, because it wasn't complete enough, or it didn't have enough data, or it didn't have the mouse model, or it didn't have blah, blah, blah. So the next time we get a paper from that journal, someone else's work, we say, well, this could be acceptable for a paper in X journal, but, for this standard, I would expect X, Y, and Z to go in here.
What's the physiological relevance?
Well, we are somehow in our minds setting what the bar should be, because we know that journal paper has currency. It has currency in our field. And so we are continuously changing what the currency is to get in these journals. But we are doing that. And we know this because we've seen peer reviews, where they just, ask for just a very unreasonable thing. It's not the journals that's doing it. It's like we are doing that.